Okay, so today we'll discuss on random variables. So what we are going to discuss is today we'll discuss with already we have discussed one. So obviously we are going to discuss what is random variable, types of random variable, probability distribution, probability mass function, cumulative distribution function, continuous random variable, expected value, variance and standard deviation, and some practice problem and summary. Okay. So already you know that what is probability, what is sample space, what is events, what are the three methods. Then you already know addition, multiplication and conditional probability formulas, right? So now let's try to understand. So random variable is basically a number that depends on chance, right? Suppose for example your age, that is a fixed number, right? So it is not a random variable. Distance from Jeypore to Koraput, let's say that it is 30 km. So it is not a random variable, right? So these are the constants. But tomorrow's temperature, number of students will be present today, or your score in the next exam, time it takes to reach village. So these variables will vary by chance, right? So we don't know the exact value before the event happens. Then from outcome to number, right? So when we toss a number, the traditional approach is you give the sample space, we write the sample space, head and tail. So outcomes are basically words, in text we write, and it is hard to do calculation with words. So random variable is you define, let's say that x is number of heads and x is 0 if tail, x is equal to 1 if head. So now we have numbers, right? So it is easy to calculate average. Now the definition of a random variable is a function that assigns a number to each outcome in the sample space, right? So basically it is a rule that convert outcome into numbers. Like for example, when you roll a standard die, so the random variable is x, the number that appears. So the possible values are 1, 2, 3, 4, 5, 6. Example 3 is tossing 2 coins, which we are doing yesterday. So experiment is to toss 2 coins. The sample space is HH, HT, TH and TT. Random variable is x is number of heads. So x is equal to 0 for outcome TT, x is equal to 1 for outcomes HT and TH, x is equal to 2 for outcome HH. So the possible values are x basically 0, 1, 2. So these are some of the real life example of the random variables, the economic examples. So about daily income, the daily income of a street vendor. So the values depends upon from 200 to 2000 rupees. Then example number 6, stock return, daily return on Sensex. Values are any percentage, it can be positive or negative, it depends on the market conditions. Example 5, unemployment, number of unemployed people in Jaipur. And example 7, exam scores. So your score in economics exam. So value depends from 0 to 100. So it depends on preparation, difficulty, luck. So now the standard notation is we use capital letters for random variables x, y, z. We use small letters for specific values x, y, z. So if x is equal to score on a die roll, so the correct notation is probability of x is equal to 3, which is equal to 1 by 6. It means probability that x equal to 3. Probability of x greater than 4, that is 2 by 6, which is equal to 1 by 3 means probability that x is greater than 4. So probability of x less than equal to 2, we say it is probability that x is at most 2, right? So what is important over here is x is the random variable and small x lower cap we write x is a specific value. So there are two main types of random variable, one is discrete and continuous. Discrete is countable values, you can list them, example is 1, 2, 3, head or tail. Continuous is uncountable values, any value in the range, example height, time, temperature. So discrete random variable, it takes countable values, example number of children in a family, possible value 0, 1, 2, 3, 4. So you cannot have 2.5 children. Example 3, number of cars sold in a day, example possible values it can be 0 to 3. Discrete is you cannot sell 3.7 cars. Example 2, x is equal to number on a die, possible values are 1, 2, 3, 4, 5, 6. Discrete is only 6 values. Example 4, x is equal to students passing exam, so the possible values will be 0 to 60. So discrete is whole numbers only. And some of the example of continuous random variables are continuous random variable is it takes any value in an interval. Example 1, x is equal to height of a student. The possible values are any values between 140 centimeter to 190 centimeter. So it is a continuous random variable. Example 2, x is equal time to complete the exam. Example 3 is weight of rice bag. So these are the different continuous random variable example. So this is one example. You can see there are different random variables examples are given over there, and you can say whether it is discrete and continuous. So we can go to next slide. So you have to identify whether each random variable is discrete or continuous. Suppose for example, number of economic books you own, it is a discrete random variable. Y is your exact height in meters, so it is a continuous random variable, right? Z is number of typing errors in a document, it is a discrete random variable. Amount of time studying, it is a continuous random variable. Okay. Now next question is, as already you know what is a random variable and what is a discrete random variable and what is continuous random variable. Next question is, what is a probability distribution, right? So a probability distribution basically tells us what values can the random variable take and what are their probabilities. So two questions we always ask: what are the possible values and how likely is each value? So the important point over here is the probability distribution gives us the complete picture of the random variable. So random variable x, let's say that the number of head in one toss. The possible values are x can be x is equal to 0 if it is tail, x is equal to 1 if it is head, and the probability is x is equal to 0 is 0.5, probability of x is equal to 1 is 0.5. So in the tabular form you can write like this. Okay, please see how you write the in tabular form, so that when you will try to read joint probability distribution and will calculate the marginal probability, it will be much helpful for us, and this is how you can plot it. Next is random variable x, the number on die, right? So already you know that we write like because you can see this is small x or specific values of capital variable, that is x is equal to number on die, that is in our random variable. So if you will add each one of these probabilities, it will add up to 1, and you usually show the probability distribution. In this case, x-axis shows specific values of x and y-axis shows the probability, right? And you need a bar chart to plot it. And what is the interpretation of this bar chart is each outcome has equal probability, and that is why it is called uniform distribution. Okay, next is, we'll go to the next slide. Then PMF, probability mass function for a discrete random variable. x. The PMF is probability of x is equal to, we write like that, it gives that probability that x equals exactly small x. So what are the properties of PMF? So basically probability of x will be between 0 to 1, and sum of all probability will be equal to 1. And PMF is just a fancy name for the probability distribution table. Okay, and what is important over here is, suppose for example, let us try to understand how we can calculate or how we can find out the probability mass function. So experiment here, the experiment is we toss two fair coins and the random variable x is equal to number of heads. So finding the PMF, the sample space is HH, HT, TH, TT, S is equal to 0, it means outcome TT, that is probability of 0 is 1 by 4, x is equal to 1, it means the outcomes, basically we are saying the number of head, right? So it means head tail and tail head, so it is probability of 1, that is equal to 2 by 4, which is 1 by 2, x is equal to 2, outcome with the number of heads are 2 over here, so you will write like probability of 2 is equal to 1 by 4. Okay, and you write the, or you can create the PMF table like this. Clear, Ajay?
Yes, sir.
You can create a PMF table, right?
Yes, sir.
Because this is how you will be writing the PMF table.
Yes, sir.
Because most important is how you write the sample space. From the sample space, you write the, like, convert into a random variable. Then from random variable you convert into a PMF table.
Okay.
Okay. Madhushanda, is it clear? You will be able to do it. Okay. So going forward, how you?
Sir, Madhu madam is asking some questions. Why you are using zero in the PMF table in chat box?
Chat box, I am not. It is. I am not able to see it. So it is clearly it is written. Na? The random variable x is equal to number of heads only. Okay. So what is the random variable here? Number of heads. So obviously head tail, tail head and TT, right? So x is equal to 0 means the outcome TT, na? Where there is no head, right? So that is why we are writing 0. Because here number of head is 0, na?
Yes, sir.
Bhakti ma'am, am I clear?
Yes, sir.
Madhusina is asking why we are writing in a PMF table 0.
Yes, sir. The explanation is very easy. I think they understood it. Even they mentioned here.
Because the number of heads only. So here
Yes, sir.
the outcome is TT, so that is x is equal to 0
There
only.
is no head, that's why x is 0.
Yes.
There is no head. But ma'am, I think if someone doesn't know how to convert into a PMF table from the sample space, I think when you will be calculating joint probability distribution and marginal probability, it will be a little difficult.
Not possible. Yes, sir.
Because this is the simplest way. There it will be bivariate,
Right, sir.
right? So it will get complicated.
Right, sir. Yes, sir.
Because if you will see the note fundamental of statistics and fundamental of mathematical statistics, let me show you. So you will see this is there, right? Fundamental of mathematical statistics. fundamental of this is mathematical statistics, right? I think where is joint probability? Fundamental of statistics. Here I think. No, it is not here, but I think it will be somewhere in the note. I'll show you. Fundamental of probability, I think here. Maybe here. Here it is. You can see
This below the
like joint distribution. You can see over here. Can you see, ma'am? Joint distribution, conditional
Yes, sir. Yes,
distribution,
sir.
and concept of independence. I think this note is there or
Yes, sir.
not. I don't know. Review of fundamental probability. It must be there. So what we are doing, it will be much easier for us to relate it. Okay. So let's see how it will be useful when we will do the slide. So now, how you can calculate the probabilities, right? Given the PMF from the previous slide for two cons, what is the probability of x is equal to greater than equal to 1? So this is the PMF. Please write it down, or you take a screenshot. Right? Bhakti ma'am,
Yes, sir.
like in this case, we usually say that at most x is equal to
Greater than 1 means it could be 1 or 2. The
less than
probability of
equal to
getting
2
either
means
1 head
at
or 2
most.
head. Yes, sir.
Less than equal to is at most, right?
Yes, sir.
So here in the question,
Okay.
it's greater than.
It means probability that x can take value is equal to 1 or it can take value equal to 2. So answer will be 0.50 plus 0.25 equal to 0.75
1 or 2. Okay. So it will be either equal to 1 or
or
probably
2.
2. Right?
Yes.
Clear? Ajay, is it clear?
Yes, sir.
So similarly, can you tell me what is probability of x less than 2?
Is it 0.25 again? 0.25 plus 0.50.
Plus 2 by 4.
2 by 4.
1 by 4 plus 2 by 4.
It is probability of x equal to 0 plus probability of x is equal to 1.
1. Yes, sir.
Yes, sir. I have also.
Okay. So then we'll go to cumulative distribution function. Okay. So for any random variable x, so CDF is some cumulative distribution function, like even though theoretically we try to calculate, where exactly you think it will be useful?
General in continuous variable, it will be easy for us to deal with CDF, not probability mass function. Because in probability mass function, there a lot of value of the variable can take. It's a continuous variable from 1 to 2, it can take many values. So it's better to calculate, better for to calculate the probability at an interval rather than calculating it at a particular specific point. Because many infinity points are there.
Yes, yes, yes. I think we did very good example in the quantitative methods 1. calculating in an interval the probability of like for example waiting in a bus stop, there are numericals, and many cases where we are more interested in interval, right madam?
Yes, sir.
So basically if you will see uh, in this case, so already this is your PMF, right? And here we can convert into a CDF table, right?
Yes.
And because it is just a cumulative one, you can see over here the difference. But we can like convert from a PMF table to a CDF table, right, Bhaktima?
Yes, sir. Yes, sir. Yes, sir.
Okay, so first of all, what are the properties of CDF? So the important properties are f of x is non-decreasing, and if x1 is less than x2, then f of x1 will be less than f of x2. F of minus infinity will be equal to 0, and f of infinity will be equal to 1. For discrete random variable, f of x is a step function, and then you can
For continuous variable, it will be smooth function.
yeah,
There will be no discontinuity among within the graph.
this is a like per discrete random variable,
Step
so it is a
function.
step function. But for continuous, as you told, it will be a smooth function, right? And you can evaluate like this, right? F of b minus f of a within an interval if it is there, right? Suppose, for example, for our 2 coins example, if you are asked to find the probability of x greater than 0 and less than equal to 2. So simply you can find out f of 2 minus f of 0, that is 1 minus 0.25, that is 0.75. So it means the probability of getting 1 or 2 head is 0.75. Then probability density function. So what are the like the problem with continuous variable is, for continuous random variable there are basically you can say there are infinitely many possible values, so each has probability of 0. Like there is one example given over here, probability of height is exactly 165.000, same is 0 only, with small change, right?
Yes, sir.
So basically for continuous random variable you can define the PDF, right? Probability of x taking the value a, it is greater than equal to a, less than equal to b. So we write integral of f of x dx a to b, right? So for continuous variable we talk about the probability over an interval, as Bhakti Mama was telling, not at a point. Okay, so you can see over here which mom was saying, PDF versus PMF visual comparison. For discrete PMF you can see the step kind of function, but for continuous PDF it is a smooth curve. So and the difference is you can see over here, and the properties of PDF are, important properties are f of x is greater than equal to 0 for all x, total area under the curve is equal to 1, and practical implication you can see over here, if you are interested to find out the probability of x greater than 165 centimeter and less than 170 centimeter, so it means you are trying to find out between height between 165 and 170 centimeter. So next important concept is what is expected value. So some of the more numerical I will upload it, I think, which we did in the PG first semester class. Next is what is expected value. Expected value is average value. So suppose basically if you repeat the random experiment many times, what value you will get on average. So simply it is the expected value. So for any discrete random variable, the expected value will be summation of x into probability of x, right? Simply you multiply each value by its probability, then add them up. Then step by step is list all possible values of x. For each value of x, find the probability of p of x, multiply x into p of x. Then you can add all these products together. So suppose this is a random variable x, which is number on a fair die. So you can calculate the expected value of x over here. I think Ajay, you did it earlier, right? This one, how to find out expected value of x, isn't it?
We have did, sir, but here is summation x into probability of x लिखा है, but where is the probability of x multiplied, sir?
Where? Here?
Here.
Here?
Yes,
1
sir.
into 1 by 6 is equal to 1 by 6, isn't it? Then 2 into 1 by 6, it is equal to 2 by 6, isn't it?
Yes, sir. Yes. Now I have.
Here it is written clearly.
Oh, okay, okay, sir. Oh, directly ଏଠି ଲେଖି ଦେଇଥିଲା ତ ମୁଁ ଭାବିଲି ବୋଧେ ଏଠି without multiplication से direct summation କରୁଛି.
Is there any doubt, Sangeeta?
No, sir.
If you will be given a random variable and you will be asked to calculate it to expected value of x, you will be able to calculate, right? If it is a random variable, means discrete random variable or continuous random variable, no problem. We can first you just see what kind of random variable is this? Is it discrete or continuous?
Discrete, sir.
Discrete. Okay, very good. Now let's see what else is there. Next slide. So this is one of the example. Example is expected number of heads. Experiment is that you toss two fair coins. Random variable is x is equal to number of heads. So what is PMF? X is equal to 0, 1, 2. Already we have calculated this earlier. Simply you multiply summation x into probability of x, right? So basically what is the interpretation over here? If you toss two coins many times, you will get an average of one head per experiment. So this is another example. The street vendor's daily income depends on the weather. Income distribution is like this: weather, then income, and then probability. Then what is the expected daily income? Okay, so you can calculate, right? Expected value summation x into probability of x. So that is 940. So it means expected income is 940 per day, and this is the average over many days and not what happens every day. So now these are the different properties of the expected value. First of all, linearity property is very important. Like expected value of ax plus b will be equal to a into expected value of x plus b, where a and b are constant. Then for two variables, expected value of x plus y, it will be expected value of x plus expected value of y. Then constant is if x is equal to c, then expected value of x will be equal to c. Okay. Then example of property 1, like for example, if x is equal to score on die, then and y is equal to 2x plus 5. So you can find out like expected value of y will be equal to expected value of 2x plus 5. That is 2 times expected value of x plus 5, which is equal to 2 into 3.5 plus 5, that is equal to 12. Okay. Expected value property, you should know it, right? Ajay, you were aware about these properties earlier?
Sir, actually, I have forgot about it.
You write it down, okay?
Okay, sir.
Or the PPT is there, right? You can note
Yes,
it
sir.
down.
I will notate it from the.
Because these are very important for the understanding those three PDF, okay, and
Okay.
mathematical properties also. Then next is why do we need variance, right? So the expected value tells us the center but not the spread. So two there are, let's say that two different situations. Situation A, daily income is 1000 every day, expected value is 1000. Situation B is daily income varies from 500 to 1500. So expected value is 0.5 into 500 plus 0.5 into 1500. So that is 1000. So same expected value but different risk. Okay. So which one is having more risk? Ajay? Situation A or situation B? Hmm?
Sir,
In
same expected
situation
value.
A you are having 1000 and situation B also you are earning 1000, right?
Yes, sir.
But which one is more risky?
My risk is where is 5 to 5? First one is, sir.
Okay, thank you. Chinmay,
Uh, Second one.
why second one? Yeah, कौन पाए second one? Hmm?
ଡେଲି ଇନକମ୍ ଭେରି କରୁଛି ନା, କୋଉଦିନ 500 ହେଇପାରେ, କୋଉଦିନ 1500 ବି ହେଇପାରେ।
Okay. So expected value, yes. Ajay, second option, okay? Situation.
Okay, sir.
It means situation A, the person is earning 1000 every day, right? But in situation B, it is varying 500 to 1500. Okay?
But we have to find out the risk. Which one is high risk?
Because the variation is higher, na, here. If 1000 is average, so there is a huge variation. So expected value tells you the center but not the spread. Okay? So
Okay.
variance measure the spread or variability. So variance will
So
give
can
you.
I add something here?
Yes, yes, please. Yes, madam.
So in situation A, where there is no variation, it is a certainty. I am certain that every day I am getting 1,000 rupees. But in
Because
situation B,
madam, here
probability.
expected value of a constant is constant itself. It means
Yes, sir.
you are daily you are earning 1000, na? So you are certain, right?
But in second case, though it indicate that getting 500 is probability half and getting 1500 is also same probability. But it's a probability, not certainty. It may happen out of 2 days, you may get 500 every day and do not get 1500 every day. That's a possibility because it's a probability. Yes.
Yes, yes, yes.
ସାର୍ ଏମିତି ଭାବୁଛନ୍ତି ଇଏର 5500 ଦିନେ ପାଇଲି ଆଉ ଦିନେ 1500 ପାଇଲି ଟୋଟାଲ ମୋର ମିଶିକି ଦେଖିବାକୁ ଗଲେ 3000 ହେଇଗଲା 2 days ରେ 2000 ହେଇଗଲା କିନ୍ତୁ ଏଇଟା 500 ପାଇବ ଗ୍ୟାରେଣ୍ଟି ନୁହେଁ ଇଟ୍ ଇଜ ଏ probability and probability may the variable may be realized may not be realized.
Visible, Ajay?
I guess, sir. Now it is clear. Okay. Thank you.
So variance measures the spread or variability. Okay. So now next is what is variance? So variance measures the average square distance from the mean. So I think I hope you will be able to prove this, right? Ajay, can you, in terms of expectation, can you prove this? Expected value of how expected value of x minus mu whole square is equal to expected value of x minus expected value of x whole square. And if you will open the bracket, what it will be? So directly, we remember this. The how we denote variance of x sigma square. Then direct formula expected value of this is Bhakti ma'am, I think this is better, right? Direct formula we can remember.
Yes, sir. The second formula is the best formula. It is always easy. You can compute it.
Expected value, first we will calculate expected value, then we'll take the x square minus whatever the expected value of x whole square, right? So that is what it is written, expected value of square minus the square of expected value. So but the intuition is larger variance means values spread out far from mean, smaller variance values clustered close to mean. So what do you mean by small variance and large variance? That is important to understand in terms of and intuition. So then standard deviation. So standard deviation already we know that it is square root of variance. And why we take square root? Because variance has squared units. Standard deviation has the same unit as the original data and it is easier to interpret. Bhakti ma'am, you want to add anything over here?
No, sir.
Like standard deviation usually the theta series दिया है तो madam, if there are two
No,
series
sir.
and if the two series are having the same standard deviation, but how we will decide
Yes, sir.
which one is the variation is which series is having more variation? Let me ask others. Sangeeta,
Sir?
if there are two series which is having same standard deviation, okay, but if I'll ask you whether the series is having the same standard deviation means there is no problem, there is the variation is same, is it true, or is there any other method from where we can cross verify? Bhakti ma'am, is my question clear?
Yes, sir. Question is clear, but I also do not know this answer.
But
This is a very good question. I never know. This is a wonderful question.
Standard deviation is same, but variance may be different.
no, not variance. I am asking that if the standard deviation of two series are same,
Huh?
whether it means that the distance from the mean, basically because standard deviation shows what? Standard deviation shows
Spread from the
spreadness,
distance from
right?
the mean.
Spread from mean, right? So
Yes, sir.
how we will know that whether the spread from mean is similar or not? That is my question.
Not
Do we need
necessarily,
to
sir,
check
the
its
spread will be same.
kurtosis?
And but if I little rephrase my question, like for example, let's say that if there are two series, this is one question, let me ask another question. Let's see. Each of the series is having, let's say that same average, okay, same mean, but different standard deviation.
Okay.
And you are asked to find out which series is having more variability. Whether you will take standard deviation as the measure or is there any other measure? Is my question clear, Bhakti madam?
No, sir. Please repeat the question.
I am asking you that if the
Madhu madam is giving some answer in the chat box, sir.
okay, what she is telling in the chat box?
Through standard error. She's telling that through standard error we can.
So standard error. No, actually we will do this in Stata. We can do this exercise. Okay, ma'am. I think
Okay, ma'am. Okay, sir.
we'll take some real data. But coefficient of variation, Bhakti ma'am, where we will calculate?
Oh, yeah. That is the question, right? Yes.
That is what I was actually looking for the answer. The answer is much easier.
Okay.
Okay, Sangeeta?
Yes, sir.
So where you use coefficient of variation?
And when we try to measure the direction of,
Direction. No. Okay. We will come back to this later on.
sir,
We'll,
when there is a presence of extreme data,
okay,
then sir,
no problem. We will come
uh,
to that. Okay.
okay, sir.
So, but first of all, you try to understand this variances squared unit. So standard deviation are the same unit as the original data, so it is easier to interpret. So that is why we calculate the standard deviation. And this is one example. Let us try to do it. Okay. Please try to do it on your notebook. Those who have forgotten how to calculate the variance, first of all. So already the random variable is number on die, right? So first already we know that the expected value will be 3.5, right, Ajay?
Yes, sir.
So if you are asked to calculate standard deviation, how you will be doing? First you calculate expected value of x square, right? So 1 to 6 x square, just to do it. Then probability of x, already you know it, right? So expected value of x square will be 1 plus 4 plus 9 plus 16 plus 25 plus 36 divided by 6. So that is close to 15.17. Step number 2, already we are saying the formula. So that is 15.17 minus 3.5 whole square. So that is 15.17 minus 12.25, that is 2.92. So step number 3, standard deviation, that is 1.71, right? So is it clear how you can
Yes,
see
sir.
that? Yeah. So next question is, suppose in the case of two coin toss, and the random variable is number of head in two tosses, and we know that expected value of x will be equal to 1, right? Isn't it? Now you are asked to calculate. You just see the notation over here. First the PMF table, then find expected value of x square, that is 0 square into 0.25 plus 1 square into 0.50 plus 2 square into 0.25. Then variance, similar way. Okay. Is it clear, Ajay?
Yes, sir.
So these are the different properties of the variance. Please, I think as we are not going to repeat again, please do it, because I am going to give exercise based on this. Bhakti ma'am, I will give one exercise based on this. Okay? Means
Yes, sir.
how to, because I
Yes,
think
sir.
I don't know whether you have studied Christopher Daughtry or not. In Christopher Daughtry,
No, sir. I have not studied him.
that is this is a very good book, Christopher Daughtry. There is a review chapter. I'll share this
Okay,
book
sir.
with you. So all these
Yes, sir.
concepts are given over there, and
Okay, sir.
we'll do the revision part. Already we have done, but I'll give you some questions from that. Okay.
Okay, sir.
So, uh, so these are the important properties. Ajay,
Again, sir.
these are the important properties of variance. Are you writing it down? Variance of x is greater than equal to 0. means variance is non-negative. Variance of A is equal to 0 if A is constant. It means no variability. Variance of Ax plus B, that is A square into variance of X. So adding constant B doesn't change variance, but multiplying by scale, variance increases, right? So I think this question was there in the net this time, isn't it? Ajay? Whether variance is independent of change of scale or not? This question came or not?
Yes, sir, it came.
Ajay, how you forgot? Which is true? Sangeeta?
Yes, sir.
What is this? What is the each variance
It
is
is, sir, it is independent of change in origin, but not change in scale, sir.
okay. So this is
Variance is
incorrect.
independent of change in origin.
This is incorrect, right? But
But it is
variance
not.
is independent of change of origin, right?
Yes, sir.
Independent of change of origin. So adding constant doesn't change variance, but multiplying by scale, obviously, if you multiply a constant, then variance will increase. By how much? By the same constant itself, by the same number. Okay? Because
Yes,
you
sir.
can see
It's not
it's becoming a square. Whatever the variance of x is there, but if the constant square, it will increase. Okay? You can cross verify. You take
Yes, sir.
1, 2, 3, 4 observation and then you multiply by one constant. That's that 2, and then you see how much variance earlier you are getting, and after multiplying how much you are getting. And if x and y are independent, variance of x plus y is equal to variance of x plus variance of y. Okay? This
Yes, sir.
is also fourth property is very important. Uh, an example I have given over here. Property 3. If x is equal to temperature in Celsius, y is equal to 2x plus 32. If variance of x is equal to 4, variance of y is equal to 2 square into 4 is equal to 6. Okay, so this is one example. Practice problem. A student takes multiple choice test with 4 questions. Each question has 4 options and the student guesses randomly. And let x is equal to number of correct, the random variable, number of correct answer. So first of all, first question is what are the possible values of x? And what is probability of x is equal to 0? And what is the expected number of correct answers? Clear? Bhakti ma'am, is the question is clear?
The question is clear.
Okay.
Correct answers.
So what are the possible values of x?
X can 0, 1, 2, 3, 4.
0, 1, 2, 3, 4, right? And probability of x is equal to 0 is probability of getting all 4 wrong, right? Since guesses are independent,
Yes, sir.
so probability of x is equal to 0 is 3 by 4
3 to the power 4. To the power 4.
to the power 4. Why it is to the power 4? Bhakti ma'am? Because if you remember, we had discussed one important theorem before one or
Yes, sir.
Based on that only,
It is a counting principle.
counting principle. Okay? Sangeeta, is it clear?
Sir, why it is 3 by 4?
Because there is 4 options, one option will be right. Probability of being correct is 1 by 4. Being wrong will be 1 minus 1 by 4. That is equal to 3 by 4.
All the answers are 4 means it will be 4.
No. Each question is, for selecting the right, there are 4 options. Each question has 4 options. Out of 4 options, one option is correct. Then probability of choosing the correct option will be 1 by 4. Then choosing the wrong option will be 1 minus 1 by 4. That is equal to 3
Okay.
by 4.
Yesterday only
Okay.
also we did similar example, na?
Yes, sir. Yes, sir. Yes, sir.
For
Yes, sir.
each question expected correct answer, the probability will be 1 by 4, right? So by linearity of expectation, so expected value of x will be 4 times 1 by 4. That is equal to 1. It means
Okay, sir.
expected number of correct answer will be 1. So basically random guessing on 4 question, you expect to get 1 right on average.
Yes, sir.
So in UGC net you are having 150 questions, right? So
Yes, sir.
in 150 questions, if you will not read anything and you will just do tick mark, then how much mark you will get based on this? Bhakti ma'am?
Yes, sir.
If you will attempt 150 questions without knowing the answer,
Yes, sir.
50, sir. 50 question we can get correct. Sir, actually there are 200 questions in
154
total.
by 4.
Sir, actually there are 200 questions. So by this method, sir, we can get 50 answers right.
but
50 questions right.
but maximum they will evaluate 150 questions, na 300 marks, right? Or 200 questions. What is the full mark?
Yes, sir. Yes, sir. I got confused. Yes, sir. I'm sorry, sir. There are 150 questions. Yes.
Then how much mark you will get? Means maximum 150 question you will attempt, right? Even though you will attempt
75,
200 question,
75 marks, sir.
huh?
75 marks.
Bhakti ma'am,
Yes, sir.
how much mark we will get in
They-
UGC net if you will gamble all the questions?
150 questions.
There are 150 questions only. So
Okay. Is there a negative mark?
every 4 question, no, there is no negative mark. So every
Okay.
4 question we are going to get 1, na? Means correct answer, right?
Yes, sir.
That expected
Out of
value
4
is that.
questions, we will get 1 correct answer.
So 150 divided by 4.
Divided by 4.
So how much it is?
37.5.
How much? 30?
37.5, sir.
37.5. So you will get how much mark?
Into 2 is equal to 75 marks. These are the number of questions. 37 question we can get correct. So multiplied by 2, each question carries 2 marks means we can get 75 marks, sir.
Okay, very good. Okay, Bhakti ma'am, is it clear?
Yes, sir.
So
Yes,
it
sir.
means 50%. You will get 50% even if, let's say that if someone is getting 50%, so is it true that she or he doesn't know anything about economics? Bhakti ma'am?
Yes, sir.
No, as for this principle, because statistics is saying this, right?
Yes.
So now let's say that
But it is a probability, sir.
is
It is a probability.
so that is what
That
that
the
is
person knows something or not, it's a probability, not certainty.
that is what I was trying to actually know the answer, because that is why interpretation is most important in statistics and econometrics, not the formula.
Yes, sir.
Because if we will rely on the formula, then completely we are saying that that person is not doing anything, right?
Yes, sir.
And still he is getting 50% of the marks. So that sounds very stupid logic.
Yes.
So next question you can see. Okay, this previous question I think it is clear, right? Next question is: a business has the following profit distribution, and what is the expected profit, variance, and standard deviation? So you are asked to think for 3 minutes. This is like not very tricky. Simply you will find the expected profit, summation x into probability of x.
Use the formula.
Then calculate expected value of x square for variance. Okay. So x square and into the probability. Then variance you can calculate and standard deviation you can calculate. So now, so what we have learned today is random variable and how you can convert outcome into numbers. Then two types of random variable, one is discount means discrete which are countable values, that is PMF, where you will be calculating probability mass function. Then continuous random variable where you will be calculating probability density function. PMF, then we have defined what is CDF, then what is expected value, what is variance, and what is standard deviation. And these are the different formulas we have already focused, and all the probability must sum to 1. And these are different interpretation of standard deviation and variance. So now with this knowledge, I think okay, so these are some of the important means common mistake to avoid. What it is saying, variance of 2x is equal to 2 times variance of x. Mistake 3, adding constant affect variance. So adding constant doesn't change the spreadness. Yeah, it's clear. Okay, so I think with this you can start reading review of fundamental probability, because already Bhaktimam we know many things, right? Or fundamental of statistics. This is better.
Yes, sir.
You can read this one. Means what is
Yes, sir.
parameter? Then what is population?
Population.
I think probability distribution, Bhaktimam will do one class on
Okay, sir.
PMF already we did. Now some of the discrete probability distribution will do, and then
Yes.
because in the UGC net it is there.
Yes, sir.
Because I think in UGC net in June 2025 MGF moment generative function came also once.
Oh,
Central limit theorem means application not very, but they should know what is PMF, what is PDF, then what are the mean variance. Okay, so I think tomorrow we will discuss this, and then we will go to the fundamental of mathematical statistics. It will take 2-3 days more. Okay, because this will be a little tough to, if you will not do it, I think it will be not good. Okay, ma'am, I will stop over here.
okay, sir.
Okay.
Thank you, sir.
So these notes are there. These slides are also there. Please review. Okay.